So let's start. Last week maybe I was working on some other upstream issues like the container image builds, and was also reviewing Sam's LBA tree pinning PR. And I think in this week I will wrap up the review and return to the crash when in the test-based test. That's it. Chunmei.
I modified the extend map tree according to Simon's comments, and I still have some questions. So we discuss it later after the status update.
Sure.
And then I designed the OMAP tree layout. So let's also discuss it and make agreement on the layout of OMAP tree.
Sure. Let's do this at the stand up. Renan.
Sorry, muted. I'm still doing scrub. Currently have the basic scrubbing working, got preemption working as far as I tested it. Working on some problems with options passing, which I changed, which I modified, but it's getting better. And other than that, I'm reading PRs. That's Chunmei's PR. Point over. That's it for me.
Thanks, Renan. Sam.
Hear me now?
Yes, I can.
Okay. It occurred to me that I can put off free space handling almost completely and do it all in memory. So the LBA tree mapping itself authoritatively represents all used space, right? If it's not mapped by the LBA tree, it's not in use. So during startup, it's just going to scan the LBA tree and count up all of the blocks in use in each segment, and then just maintain that map in memory. It's like a few thousand entries. It's basically free, like a megabyte of space. It's a little expensive for the initial scan, but we can improve it later if we need to. And the main trade-off during operation is that when cleaning segments, we'll have to do a bunch of reads to find out whether blocks are still in use or not. But the truth is, for QLC Flash in particular, I think we always want to trade reads for writes until we have proof otherwise. So I think we'll go ahead and implement this, and we'll do some performance testing and find out how it does. It has the benefit of being super easy. So I'll be able to get this and segment cleaning done at the same time, I think. It's still correct. We're still writing down transactions that represent whether things are used or not. It's just that on startup, we'll have a structure we'll have to rebuild.
I think we can forward it, right? Because we don't reboot OSD all the time.
Well, I'm not even sure how slow it'll be, to be honest. Okay. Remember, we don't have to read the whole disk. We just have to scan the tree itself. And for a fast Flash device, I mean, yeah, I'm not convinced that it's even a problem. We'll have to see.
Okay.
If it is a problem, then we'll do the thing we'd have to do anyway. So it's not like we're losing anything. Anyway, that's what I'm working on now. In a week or two, okay. I'm off next week, so this will probably take several weeks, but after that, we should have enough that I'll be able to wire up something stupid and do performance testing with FIO or something. It'll be below the level of the rest of the object store functionality, so it doesn't require anything else, just transaction manager.
Okay. For what it is worth, I'm still struggling with the template because somehow the entry mover does not go to compile somehow. I will get it done. The entry mover, you recall I have a entry mover maker which tries to, but somehow it's failed to find the right entry mover, and it's just the compiler complains that it can that the entry mover is an incomplete type, so I'm still struggling with it. I will try to come up with a unit test, which just exercise the entry mover, try to find out the minimal reproducer, because hello world example works for me, but when it comes to entry mover, it fails. I will try to find out why and to try to finish up on the tree in next week.
And Chenwei, we'll talk a bit about at the end of this meeting, I think, about the other thing. That's it.
Thanks, Sam. Xuehan.
Last week I was trying to implement the interruption mechanism for IO execution, and right now I'm working on replacing SeaStor features along the IO execution path with error feature. After which I will try to embed the interrupt condition into the error feature, and that's all for me.
So it's still work in progress, right? The interrupted
yeah.
continuation in iterator.
Yeah. Here.
Okay. Because I guess Drake might want to take a look at it.
Okay.
Update in the pad. Thanks, Xuehan. Yingxin.
For the Ono tree, the unit tests for internal node insert is working, and for the implementation, the templatized code is mostly ready, and I'm working on the rest of to-dos to pass the tests.
Sorry, what's the last part? I think you mentioned that the internal insertion now works. What's the next step?
I'm currently the next step is the internal. I will first try to implement the unit test for the internal node split, and then using those tests to implement the split to complete the split logic.
I see.
For the internal node. Then I will start working to make it work on the SeaStor block layer. So that's
adapt it to the LBA tree implementation, right?
Yeah.
Okay.
That's the plan.
Thank you. Before moving over to the extend tree, anything else? Okay, Chenmei.
Okay. Let's continue discussion, Sam. So you don't think error extend offset is needed in the extend map. So, but how the node remember where the data starts?
Let's back up a level. So I don't think it's ever a good idea for us to map an extent with unused space. First thing. So if, let's say at some point an object has a 4K extent mapped, and we overwrite 1K of that, I claim that we should rewrite that entire extent. We should not keep 3K of it and write a new extent with only 1K in it. So I think the same is true of larger extents. So let's say we already have a 16K extent written, and that might happen if a user actually, or if a RBD actually sent down a 16K write for whatever reason. Right? If we get a 4K write in the middle of that, I think what we should do is not punch a hole in the middle of the 16K extent and remember two old references to the same extent plus a new one in the middle. I think we should split it into an 8 and 2 4s. Or a 16 with an actual mutation in the middle. I don't really care. But we shouldn't leave a partial reference in the extent map. So for that reason, I think we should go one step further, and the extent map should always be block and length aligned. So if the user submits a 200 byte write in the middle of an object, then the layer above the extent map, whose only purpose in life should be remembering the mapping from the extent offset, or from the object offset to the logical address, the layer above that should say, okay, this is a 200 byte write, so I'm actually going to grab the the 4K aligned extent that contains it, or possibly two of them, right? If it happens to cross a boundary, it should ask for all extents that cross that padded out value. Then it should return the set of extents that result from the right, whatever that happens to be. If we do it that way, there's never, ever, ever a reason for the extent map to not map an extent that starts at the beginning of an object, or of an extent. At least I can't think of a reason why we would need one.
So Sam, so it's the extended tree is more like allocated round up to the multiple of blocks, right?
Yeah, exactly.
Okay.
I don't think there's any reason to do less than that. Like, we're never, ever, ever going to do allocations that are unaligned. Like, it makes no sense. 4K alignment exists everywhere in the block stack. Like, if we get a 200 byte right, it's nothing in the stack assumes that that's aligned. There's no way.
So when asked the RBA allocate one page, for example 4K, and object write to the offsite 100, they write to the 4K offsite 100, right?
I claim that something will happen above your code that makes sure that it only ever asks for the whole 4K extent.
Yeah, so the write flow will allocate the 4K from RBA.
Yes.
Right?
Yes.
And they only write to from the 100, the offside in this extent, 100, for example, 100, in your example, write to the 100. It's not from the extent beginning. It's just from the extent 100 within the 4K.
Yeah, that's exactly right. Yeah. That's normally how this sort of thing works.
You mean in the extend map tree, we needn't record that the data start from the 100.
Because it doesn't. It starts at 0, as far as the extent map is concerned. It's just that the first 100 bytes are zeros.
Extend map tree only record that from object 0 to map to the RBA address at the length of 4K.
Precisely.
But so ONode should do more things to remember that the data start from the 100 side.
No, Chunmei, it doesn't have to. The first 100 bytes can be zeros.
Yeah, but can be 0. But when you read
it'll read data, zeros. There will literally be zeros on disk. That's what it means to write to offset 100 in a Rados object. The first 100 bytes are zeros. Nothing special has to happen. The only trick that actually does matter is that the ONode needs to remember that the object ends at byte 200. That's the only tricky bit.
And extended map tree only record how long the RBA allocated at 4K, not the real data length.
That's correct, because the extent map doesn't care. The ONode cares. So the ONode needs to remember that the object's real size is 200 bytes.
Where the ONode save that?
In a field called size. The size of the object is the only edge case here. For everything else, within the object, either there will be an extent map or there won't be. If there isn't, then it's a hole and it's 0. If there is, then whatever the byte's there, that's the answer. There are more sophisticated strategies, but I don't want to deal with them now. And they require a hell of a lot more design than we've done so far. For instance, if you're going to use partial, if you're going to remember a partial extent, you need a way to figure out where they are, because you're leaking space, right?
So Sam,
you see what I mean?
Words, I don't really get it. So in other words, the extent tree just allocates the disk space in the unit of block size, and when it comes to the extent tree, we are obliged to keep track of the extents in the unit of bytes.
No. In unit of pages. Or they might be bytes just because it's easier to do, but they'll always be block aligned, page aligned, whatever. Whatever the minimum allocation size at the transaction manager level, that's what extentmap will track.
So if user wants to write a memory chunk starting from 4122 bytes, so it's his or her responsibility to read back the bytes start from 400, right, 4000, and write it back at the 4100.
Yes, the user would have. So in that, it has to work that way anyway, because you can only read whole blocks. So if you get a write at offset 4100, you have to request all of the extents that overlap that block. Do whatever you're going to do to them, and then write back the results back to the extent map. It might be that you mutate the blocks in place, in which case you don't have to do anything to the extent map. It's just journal deltas. Or it might be that you have made choices that, let's say now the extent is old and you want to rewrite it. So you'll create a new extent, copy the data over to it, and then replace the logical address in the extent map. But that logic needs to happen above the extent map for several reasons. First, extentmap.h is an interface. From this, I infer that the goal is to later have other implementations. We want the choice of representation on disk of the mapping to be independent of the choice of policy for when to do in-place writes versus when to do replacements. The only thing I want the extent map doing is managing the B tree. Everything else I want to live in the layer above it. It's important.
Okay, so that will be much easier to.
Yes. It's just a B tree. All we're doing here is maintaining a mapping from numbers to numbers.
And the unit of the allocation is just the blocks or pages.
Yeah. And that's not even the extent map's problem. You can add asserts to that effect if you like, but it's the user's problem to make sure that that happens.
Okay.
And you see how this works at the next layer up, right? It's a bit like how SeaStor has alignment requirements on blobs.
All right. Yes.
That's exactly what we're doing here. Now, later on, if we want to do something clever like tail packing, which is the thing where you take the ends of objects, which, for instance, for very small objects, let's say you have a 200-byte object, you don't really want to use a whole 4K extent for that, right? We're going to for now, but you don't really want to. So what you could do is the transaction manager could remember like a block it has on disk that it's packing little bits into. You would then update extent manager. You could either update extent manager to be able to remember more about this, to say, this isn't a real extent, this is a blob that has separate ref counting rules. Or it could, if it's just the tail, it could be an extra member of ONode, because there would only be one of them, right? Just the end of the object. That would be enough to optimize for small objects, because in that case you wouldn't use an extent map at all. In fact, you'd want to avoid the extent map because it's just space overhead. It would be, in that case, it's a 200-byte object. You don't need to map extents. The whole thing's in the tail, right? So there are a lot of versions of that where the extent map never has to know. So I want to put off worrying about it until we have a more concrete design.
Yeah, we can start with.
And there's a good chance that, for instance, if we're targeting RBD, there are no 200-byte objects in RBD ever. They're all 4 megabytes. Moreover, writes already come down in page size increments anyway. We don't get sub 4K size writes. Not a thing. Not really. Because it comes typically from a file system's page cache, right? In real life. RBD,
in that case, Sam, is it possible to make it a configurable option for the unit size? Because in the case of the RBD,
Yes, what it's going to be is it's going to be that the extent map never maps things smaller than the transaction manager's minimum block size. So it's not even a config setting. It's an API call. You just ask the transaction manager what the smallest size is. I haven't bothered to set it up, but it's 4K for now.
I mean, in the case of the RBD use case, because if we can determine at the very beginning that the pool is only used for RBD, we can save a lot of metadata space for keeping track of the 4K alignment block range allocations. If we know
no. It's not RBD that you're optimizing for there. RBD is already what we're optimizing for, right? We're already not tracking allocations smaller than 4K. There's nothing better we can do.
I mean, we can track the allocation unit like with
We're
4
not going to make
megabytes.
it smaller than. Right,
No,
but
I'm not.
that's no. Okay. The object size is 4 megabytes. Writes
Yeah.
can be as small as 4 kilobytes.
Oh, okay.
Do you see what I mean? What I mean is, it's not that we don't get 4K writes; it's that we don't get 200 byte writes, and we definitely don't get unaligned writes
Okay, I see.
because it comes from the page cache, right? Page cache size is 4K, so typically we're going to get multiples of 4K, somewhere between 8K and 12K. I think are most common.
The page size is not always 4K.
It isn't always, but it's either way. Yeah. I think I'm safe in saying that we're not going to get 200 byte writes, not from RBD, not normally.
I see. But it reminds me that on some settings like ARM, it's very possible to have like 16 kilobytes page.
I understand, but it's not smaller than 4K.
Right.
So 4K does the trick. That's a minimum size, not a maximum size, right?
Because in BlueStor, there's a PR that tries to change the page size to 16
minimum
kilobytes.
Size.
But yes, but
right.
Sage negated it because he mentioned that we don't support like 4K any page size, not 4K. So I'm just wondering if we can.
We don't have to, Kiefer. So this doesn't matter. So if we get a 16 byte write, or a 16 kilobyte write, we're gonna do a 16 kilobyte allocation. 4K is a minimum, not a maximum.
I'm wondering if we can have a minimal block size like 16K.
Why would that be good? That's what I'm asking. I don't understand why it matters.
Because it could save the
right,
the
but the point is,
for tracking
if we actually get a 16K write, we're going to do 16K allocations anyway. We don't need to set it as minimum. That's just what we're going to do.
Okay.
Why wouldn't we?
Mm.
Like, we're not going to go out of our way to break things into 4K pages. That doesn't make sense.
It depends on how we track the free space. If we track free space using bitmap,
we're not tracking free space literally at all yet.
Okay.
All we're doing is what we're doing is we're tracking the total amount of free space in buckets. So if there are 1,000 segments on the whole disk, then we track the amount of free space in each segment. Once it gets low enough, we go through the segment and remove everything that's live. After that, the segment is completely free. We don't remember which 4K pages are live. We just remember whether an entire segment is live.
Oh, right.
See what I mean?
Okay, it's quite different from the...
It's quite different, yeah. There's actually...
we are using in BlueStor.
Yeah, allocation is actually free in this model. What's expensive is garbage collection.
Okay.
Yeah. I'm not saying you're wrong. We will eventually need to tackle some of these things, but I only want to tackle the things that matter. At least for now.
For now, yes.
Chunmei, did you follow that?
But for extend map tree, I understand. But for the other above the layer, I'm still confused.
So the idea is that we don't really get 200 byte writes. It's not a real thing.
Mm-hmm.
For RBD, at least, we're mostly going to get 4K and larger aligned writes.
Yes.
Because it's a block layer, right? Block layers don't tend to get itty-bitty random writes. Most disks can't even handle it.
Yes.
So for that reason, we don't want to optimize for little writes. It doesn't make sense. So if we do get a little write, we're just going to do something stupid. We're going to allocate a big space around the little write and treat it as though it were a big write. We can choose to do something smarter later, but that's good enough for now.
Okay. So we don't care about if read out the 0 or something like that. So we needn't record the offset in this extent, right?
What's that? Sorry, I didn't get the beginning.
Yeah. So the extent tree only record the beginning of the page LBA allocated and the length is this LBA allocated, right?
Yeah.
To map to the object block aligned offset in the block in the object. So since we don't record where the real data offset in this extent.
Well, it's important to remember if it starts at 100, there is real data before 100.
Yes,
Okay.
we don't care about if we read out 0. It doesn't
Right.
matter.
No, it does matter. We have to read out 0. We're required to.
Yeah, we read out 0,
Yes.
but that will not influence the result, the read result. It's just 0.
No, you're misunderstanding. If it's the same as writing to like if in normal POSIX, if you write to the 1 gigabyte byte in a file that is empty, the first gigabyte of the file is zeros. It's not optional. You really do have to return 0. You won't typically put the zeros on disk, but if anyone does do a read to those extents, you have to return 0. So in our case, if you write to a very far out extent in the object, like 4 megabyte, and the object is empty, then we'll allocate a little 4K chunk around that write with zeros except for the part you wrote, and the rest of the object will be implicitly 0. But the important part is that as far as the extent map is concerned, it doesn't care. The extent that it maps at whatever offset is the data. And the user above will have ensured that whatever data actually got written gets written into the extent, and the parts that need to be 0 will actually be 0. So the read results will be correct in the future.
No, the 0 has map in the extent map for the 0 page. No map in the extent map, right?
So let's say you do a write at 4K plus 200 bytes, or
Okay.
4100 bytes from Kifu's example. Well, is that 4K plus 100? Is that 0x4? Yeah. Anyway, so the what will happen is the user layer will allocate one 4K extent starting at 4K. So the extent map will contain a single extent beginning at 4K of length 4K.
Yes.
The first 100 bytes of that extent will literally be 0 because they have to be.
Yes.
The next 100 bytes will be whatever the user wrote, and the part after that will be 0 again, though that doesn't matter as much because it's not really part of the object.
Okay, yes.
So if the user does a read at, like, let's say 1K to 2K, later on, the user code will map that to, okay, I need the page from 0 to 4K. It will find there is nothing mapped.
Yes.
And it will infer, oh, this is a whole. I return 0. Right?
Yes.
Okay, that's all that's going on here. It's really no different from the way BlueStor works.
Yes, the same.
More like, this is a normal way of handling things if you don't expect to handle a lot of small files. In the future, if we do need to handle small files, we will have to do something smarter. But this will work for now.
Okay.
Like in extremis, we could pack small bits of object into the O-node itself even. Like, there are a lot of little tricks we could play. So we can think about ways to do that later, I think. For now, we should focus on RBD.
Okay, so I think I understand what the extend map tree do.
Me too.
And I'm okay with other designs. I just want, like, when you're writing out your interface, people reading or reviewing your code, and later on, people reading your code because they need to either use it or expand upon it or whatever, or just understand it. They're not going to be able to guess necessarily how you meant it to be used. So it's really, really helpful to have at the top of the interface, for instance, just an example of how you expect the user to work. And each method should have an explanation of what it does and why.
So,
does that make sense?
So nobody care about where the data is stored in this extent, right? The offsite, nobody care about it.
What do you mean by that?
For example, the user allocated 4K, but data write to the 4K plus 100.
It definitely cares. It has to be at 100, right? The user didn't write 100 bytes. It wrote
the
100.
offset is 100, so nobody recorded where the data would offset.
Why would they need it? Why would they need to?
I think the caller is responsible for this.
No, hang on. Why would they need to?
So we read the whole extent out.
Yes, that's correct.
And from the before the 100, it is 0.
Yes, it literally has zeros. Right.
Okay, so if the data length is 200, after the 300, it's 0.
We're free to do whatever we want there, but yes, it should probably be 0. The O node itself, the next layer up, will know that that's not object data. But
how
yeah, it should
ONode
probably
know there is no data?
The O node can record the size. We have to do that anyway because we have to be able to return the size if asked.
Oh.
This is a special case of the last extent. This isn't true of any other extent, right? Because the object can only have one end.
So if the data start from the 100 to, for example, to 300, and the read size is 500.
Yes.
It returns from 0 to 500, right?
Hang on a sec. From where did the read start?
The data start at 100 to 300. The length.
No, actually at 4100 to 4300. But yes.
Yeah, 4100, 4K100 to 4K300.
Yeah.
And if the read operation read from 0 to 500, 4K 0 and to 4K plus 500, we will
0 to
return
4K
all
plus
the
500. No, we'll return up to the end of the object, which is 4K plus 300.
But we don't know.
Yes, we do. The O node does. Yes, we do. The O node does.
Oh, no.
The size of the object is 4300, or 4K plus 300.
So, Kefu, where you save the length, the real data length?
I think the O node should be tracking the real size of
the object. Yeah.
Yeah, the object.
And maybe the other parts have the other data extent.
No. Because if any other extent in the object, if it has zeros, it's zeros.
So you mean there's no zero hole between the extent?
I think there are two cases, right? One is the host with the boundary of the block, and the case like external host and internal host. In the case of internal host, when the client, the caller allocate a chunk, it writes the data into the, like for example, like at the 100 offset, the chunk before the extent between 1 and 100 is 0, because that's how the data is written to the disk.
Well, and because we defined it to be 0, that's the rules. It's not an accident. The Rados protocol actually requires that.
So the ONode only recorded the total size of the object, right?
Yeah. So let's say the sequence of writes looks like this. Oh, 4K. So we've done two writes.
Use a pad for illustrate the extent.
So we've done two writes here. We've done to an empty object. One at 4K plus 100 for 200 bytes, and a second at 12K plus 100 to 200 bytes, right?
Mm-hmm.
So what happens here is the first write causes the object size to be 4K plus 300, right? That's not optional. We're required to do that because of the way Rados works. Several components rely on this. So after the first write, the size is 4K plus 300. After the second write, the size is 12K plus 300. So the question is, what if we get a read at right? That's what you're asking? Don't I?
Yeah, it's written 0, right? Because there's no mapping.
The first one doesn't have a mapping, so it returns 0. Correct. The second one does have a mapping, though. There's data mapped at 5K plus 100.
But the two map is 4K and 12K, no 5K.
The 4K one is 4K in size, right? We're always doing 4K pages. So the extent at 4K extends from 4K through 8K. So that 5K plus 100.
The first map is 4K pages, right?
The first map is at 4K, yes. So the very first read, the 100 read, yes, there's nothing mapped there, and you get zeros implicitly. That is, you get back 200 bytes of 0, right?
Mm-hmm.
It's a successful read, you get data back, it's just all zeros.
Yes.
The second one at 5K plus 100 for 200, that actually does lie in a mapped extent, right? It's that first extent we mapped, 4K plus that first 4K extent.
4K aligned, yes. So
we literally, that extent has 100 bytes that were whatever the user wrote, and the rest of it is 0.
Yes, that has map, but no data.
It has data, zeros.
Yeah, zeros.
Yes, it
yeah,
has
zeros.
data.
There's a literal extent that has 4K of zeros and 100 bytes of something at offset 100, right? But the rest of it is zeros, and it really is data.
It's
Like, there's no, later on, there's no difference between those zeros and the 100 bytes the user wrote. In fact, those 100 bytes could be zeros. We may not have bothered to check. Okay, similarly, the 13K one, that actually falls past the end of the object, so you get an error message. Or an error code, rather. E range, maybe? Can't remember. See what I mean? It's within a mapped extent, but the O node's going to notice that it's past the end of the object, and it's going to return an error.
How about this one?
What do you think it would return?
Read and...
So 500 bytes starting at 4K, what do you think would happen?
It return 500 bytes, right?
Yep.
The first 100 is 0. And...
No.
Wait, what? Sorry? The first 100 is zeros. The last 200 are zeros.
Is zeros.
And
right?
the user's written bytes are in the middle. Yeah, exactly.
Okay,
Does that make sense?
So we return the 0 data. We don't care about the real data length. Just return the 0
no, but
data.
I keep saying this, and I need to say that it's really important. The zeros are real data.
Okay.
There's no difference between those zeros and zeros the user actually wrote.
Okay, I see.
Like, there's nothing preventing the user from actually writing zeros in. If the user writes an entire page of zeros at offset 0, we actually could just not do the mapping, right? We already have rules that say, we were going to return 0 anyway, so it's a no-op. All we have to do is update any end time or whatever stuff, right? There genuinely is no difference between implicit zeros because there's a hole and zeros we remember because it happens to fall into an extent we bothered to map. From the user's point of view, it makes no difference. They can't tell they can't tell one from the other.
Okay, I see.
Cool.
But in our the first phrase, we choose to be not smart, to optimize out the internal host, and just to write down the whole page down to the disk.
Oh, I mean, we will optimize out internal holes. Remember, we're talking about crumbs that are of the size of a few kilobytes, right? But if real RBD objects are 4 megabytes in size, that's 1,000 of these guys. So if we get a few 4K writes spread throughout the object, we're not really going to fill that whole 4 megabytes. We're just going to have a few pages mapped. We will still optimize for internal holes. We're just not going to optimize for 1 kilobyte of internal hole.
Yeah, by internal host, I mean the host in the boundary
within
of 4K.
an extent. Yeah.
Yes. I think it's even more difficult for us to track the internal host in the.
And it's not just
boundary.
more difficult. There's a fundamental trade-off, right? The more finely you want to track that, the less metadata you can afford to use to do it, because the size savings are so small. So yeah, it's not really worth it. Plus, the overall metadata size gets bigger, so you need to spend more CPU cycles finding the right extent. There are more branches. You have to do more offset calculations and corrections. It's just more complicated. And since we're never going to get unaligned writes in the first place, it's not worth optimizing for.
Okay, so the extend map tree only keep have the interface find extend and remove extend, add extend.
Yeah. I think one day in the future, we'll want to add a more sophisticated thing to let us add a batch, but that's good enough for now.
Okay, just the three. Three is enough.
I mean, I think so. But again, my goal here is to explain our reasoning so that you can make, your own informed decision. Like, we could be wrong. We could have overlooked something.
Okay.
So does this make sense to you? Do you feel like, is that enough?
Currently, I think so.
Okay, cool. Like, I can dictate an interface. I'm just trying not to. You've spent more time thinking about it than I have, I think.
Okay, I have no problem.
Cool.
And let's talk about OMAP layout. OMAP tree layout.
So the key of the OMAP is the variable size strings, right?
Yes, the key is variable length string and the value is variable length string, right? So
Yep.
the OMAP tree will provide the following interface: insert update pair, delete pair, and get value by key, list pairs of keys and values. So that's the currently Ceph OMAP provide the interface. And
it also allows us to filter the OMAP.
Can you see my screen? Can you see my screen?
No,
no.
I don't think so.
Can you see?
Yes, now we can.
Yes. Cool. Okay. So the OMAP current we will provide this kind of interface: insert, update, delete, and get value, and list pairs of keys and values. So this is the current Ceph OMAP provider function.
Tell me, what do you mean by list keys? Just a range query starting from a given prefix?
Yeah.
Okay.
List all the keys, attribute keys. So according to this, we need to list all the keys, list all the pairs, and we have to use the B+ trees. The leaf should be linked together.
Yeah.
Okay.
You don't strictly have to, but I see what you're getting at.
Yeah. So, and OMAP tree, so each O node will have his own OMAP tree, just like extend map tree. And the OMAP tree, the key is variable length string, and the value is for the internal node. Internal node, the key is variable length string, and the value is fixed length logical address. And for the leaf node, the key is variable length string, and the value also variable length string. So the internal node, the layout looks like this one. So there's some paper, the second paper, introduced the string key, how to arrange the string key, and they put the string key to the right side, and the left recorded the offset, and pointer to the other node.
Yeah. Okay.
Yeah. So that is the O node, not O node, OMAP tree internal node. So the string key is on the right side, and left has recorded the offset where the key is in this layout, and the next pointer to the other node. Now next
there are
n-1
values on the right?
Pardon?
n-1 values on the right, I think.
In minus value.
Val n, I think that's val n-1. Traditionally, there are one fewer pivots than keys. And that's usually what you refer to the things on the right there as, pivots.
You mean LADDR?
No, val.
What value?
Number of values.
Here,
Yeah, there
Is
should
the
be n
number
minus
of
one of
keys,
them,
not
not
one.
m.
not m.
N minus
Yes,
1.
the
Minus
total
1.
number
Oh,
of the keys should be n. So the last one
Yeah.
okay.
of the
And
index of last one
traditionally,
should be
those
n
are referred
minus
to as
1.
those are referred to
Yeah.
as pivots because they may not actually be any key that actually exists in the database.
Yes. So it shouldn't be the key, but here we just put the key instead of the real key is the value here.
No, I know. I'm just pointing out that they're not necessarily keys. They're generally referred to as pivots. They're like keys, but there may not be any actual key value matching
Yeah.
those values. It
Yeah.
could be a truncated version of them, for instance.
Yeah. So this is the inner node. The leaf node is this all. The value and the key pair also on the right side, and the left side recorded the key offset and the value offset.
That one's n of them. If that's the leaf, that's n, not n minus 1. Sorry. The n minus 1 part is only for the internal node.
Oh.
Yep. Oh, and key n minus 1, that's n. So I don't know exactly what design you're using, but the standard way this works is for the internal node, you have n pointers to child nodes. And between each two of them, you have a pivot.
Between two.
Which is why there are n minus 1 of them. So key space n minus 1 in the internal node, that should be n.
N?
Yes, that should be n. Right,
N?
that should be n.
Okay.
Val n minus 1 should be n minus 1 because there's one fewer of them. That's correct, I believe.
That's correct.
Probably.
Okay.
I mean, you tell me. I can't be sure that that's what you're doing, but I think that's right.
Yeah. So that is layout for the inner node and the leaf node. So the string, the key string and the value string also both stored in the right side, and the left side is fixed offside, fixed length offside to record where the key string and the value string is. So that is easy to calculate the position for each atom.
Hang on a sec. Why key offset and val offset? Is that just so that you don't have to? Oh, I see. Okay.
Okay. So that's fine.
I mean, I think so. Yeah. Seems pretty standard.
Yeah. So just make sure the layout it works.
Upper bound
And
of the,
Are you worried about storing the upper and lower bound of each
size
node?
pardon, Yinxin? I can't hear you.
My question is there upper bound size of the key and the value? So what is the maximum size of the key, the string key and the string value?
So I don't know.
There isn't actually. So my suggestion is that if a key becomes too large, allocate a separate extent for it.
Allocate a separate page, right? You mean?
Yeah.
Yeah. So the offset will be the pointer for the next
Honestly,
for the page.
Honestly, for now, do the simple thing and return an error early if something in the transaction has a key that's too big. Set a maximum size for the key and the value and just do it that way. Way simpler.
Yes.
RBD
so
doesn't set big OMAP keys, so this isn't really a problem for now.
Okay. So if the key
Later on, we'll have to do something smarter, but it's fine for now.
okay. So I start the next pointer to the next leaf in the header is okay.
You are storing the pointer to the next header in the leaf. So
Next leaf node, next leaf node.
Yeah, so if you do that, it seriously complicates split and merge.
Oh.
Yeah.
I mean, you'll notice it as soon as you start writing them. It's much more difficult.
So where you store the next pointer?
No, I mean having a next pointer at all has this property.
Oh. So, but when you list all the objects, what you do?
You do the same thing you always do when you're listing a recursive tree. You recurse up to the parent, get the next child, and recurse down.
So not use the next pointer.
I mean, it's not a bad optimization. I'm not saying don't do it. I'm saying it's complicated.
Oh, okay.
And it is just an optimization. You can do scanning without it.
But
I see.
when you traverse down to the leaf, it's very possible you keep track of the parent address and even the parent nodes. So if you move over to the next one, probably you can just query the.
Or just using simple recursion, you return
Yeah.
everything in that range from the leaf, and then
Oh,
the
I see.
parent calls back to the next child, and so on.
Yeah, I see. Thank you.
Yeah.
Okay.
I mean, I'm not saying a B plus tree is a bad idea. I'm just saying you don't strictly
Yeah,
have to.
I will try to find how to use the next pointer in B plus tree, if it is not very complex.
But the downside is that you need to ping the parent node in the memory or locate.
That's not hard. I mean,
Yeah,
I'm not worried about that.
Okay, let's. Oh, thank you.
thank you, Tremaine.
Yep, that's
I have a question. I have a question which is not directly related to the presentation. It's regarding the resolution of the file. I tried to work yesterday with Gabi on code, and what the resolution I got was what I got now, which was very hard to read. Do you know how to solve this when sharing a screen? How to share it with file resolution in BlueJeans or Google Meet or?
It might actually be easier to find. I think there's a Visual Studio online in-browser solution where you can both log into the same thing and see it. That might actually be better. I'm wincing because I don't have a good solution.
Okay, I thought someone solved this one. So,
it's up to it's just up to whatever BlueJeans thinks it can get away with streaming resolution. I don't think it's really designed to do a good job with text. Sometimes it works, sometimes it doesn't. You can also make the text really big on that board. Sorry?
Yeah, of course. I see the same with Google Meet, and wondering if there's some setting that should affect it.
Not that I've seen. Although, I don't know, maybe
Okay.
I'm wrong. Maybe they do have a way to make it better.
But you're right that sharing code with Visual Code, working together with Visual Code might.
Yeah, I would anticipate that it would be a bit. I'm not sure how you actually point it at a code base that you already have. I don't have a good sense for that, but
It
if there
works.
is a solution,
I tried it in the past. It works.
that's cool. Like their online one? Neat.
Yeah, I tried, but I actually did it with the real Visual Studio, not the code. I tried with code too. It works nicely. With Visual Studio, it works very nice. Working with a team on the same code. Okay, thanks.
So anything else?
No.
Okay. So see you next week, and have a good one.
Cool.
Later.
I'm off next week, by the way.
Okay.
Later.
See you the week next week.
I'll probably still be available via email, though, if anyone has questions. Later.
Okay. Have a good time.
Okay, bye-bye.
Bye.
Thanks. See you later.
Bye.
Later.
Bye.